In this video, I'm going to show you how to simplify radicals using your graphing calculator. Specifically, I'm going to be using a TI-84 graphing calculator. This will likely work the same way with any TI graphing calculator. So, simplifying radicals. Here's an example problem. You'll notice on the screen I have a bunch of stuff right here written. These are the calculator steps to simplifying it. So at this point, this would be a good time to pause the video if you've already watched it and wanted to see the calculator steps written down. But let's go ahead and try this. It says, which is equivalent to the cube root of 48 in simplest form? So what you can do is take your graphing calculator, and we're going to go to y equals, which is the top left button up here. So click y equals, and we're going to put in exactly what it says right here. So it says put in the radicand. The radicand is whatever number is under the radical. So here the radicand is 48. So we're going to enter 48, that's the radicand, and divide it by x, and the exponent on that x is going to be whatever root we're taking. So we're going to divide it by x to whatever root we're taking. We're taking the cube root, so we're going to divide by x cubed. That's why this is x cubed right here, x to the third power. To do that, you're going to type x by hitting this button to the right of the alpha button, and then hit the caret key to get into the exponent, and then put 3 up there. To get out of this exponent up here, you can just hit the right key. So it should look like that in your calculator. You should have that typed in. Now, to get the answer, here's what we have to do. We have to go to the table. To get to the table, it says it right here. You're going to hit second, which is the blue key, and you're going to hit graph, which is the top right key. This is going to open the table. So I'm going to hit second, and I'm going to hit graph. You need to start where x is 0. That's what it means by start at 0. Okay, if yours is not started at 0, maybe someone else is using your calculator to start at some weird number. To get it to start at 0, you hit second, window, and where it says table start, you want it to say 0. You also want this triangle table, delta table, to say 1. That just means the table and the x's is going to go up by 1s. That's what we want. So start at 0, go up by 1s, and go back to the table. So second, graph to access the table. Your answer is going to be in here, where you have the largest x value, where both x and y are whole numbers. Okay, so the rules are the x has to be as big as possible, and x and y have to both be whole numbers. So if we look here, right here in the y's, this is where it starts getting smaller than 1. So this is where I know I can stop. So I have 4 and I have 0.75. 0.75 is smaller than 1. So my answer is going to be between 0 and 3. It's going to be one of these choices here. Obviously 0 is not going to work. That's why it gives you an error, because you're dividing by 0. So it's a dividing by 0 error. We have two choices here. We have 1 and 48, 2 and 6. 3 is not a choice because this is a decimal. We need them to both be whole numbers. So it's either 1 and 48 or 2 and 6. This number in the x column is going to be the number outside your radical when you simplify it. And then the number in the y column is going to be what's left under the radical after you simplify it. So this means 1 cube root of 48 or 2 cube roots of 6. We want the x to be the largest possible. So the largest x would be 2, so my answer is going to be 2 cube roots of 6. 2 cube roots of 6. So let's go back to this problem. Here's our choices. The one that represents 2 cube roots of 6 would be choice A, 2 cube roots of 6. If you want another example, let's say instead of a cube root, we wanted to do a square root. So let's just do an easy one we can easily do by hand. Let's do the square root of 18. You probably learned in your math class, or hopefully you learned it, is to simplify these, you usually can make a prime factorization tree, which means break 18 down into a bunch of prime factors. So 18 is divisible by 2, and 2 is prime. That would be 2 times 9. 9 is not prime, so we have to break it down further. 9 would be 3 times 3. Both of those are prime. Once you have all primes left in this tree, you know you're done. So the square root of 18 is going to be the same as the square root of 2 times 3 times 3. Since 3 times 3 is a perfect square by definition, that would be the square root of 9. And we still have the square root of 2 left. We can simplify the square root of 9 to 3, so the answer to the square root of 18, or the simplified version, I should say, of the square root of 18 would be 3 roots of 2. Hopefully you know how to do that already. Okay, so we're going to do the same thing and try to get the same answer in the calculator. So the calculator steps are right here on the screen, except now we are going to do the square root of 18, and we said the answer should be 3 roots of 2. So let's try it. So in the calculator, you're going to go back to y equals the top left button, clear this out, what we had before. You're going to do the radicand first. So the radicand here is 18, so I'm going to do 18 divided by, and then we're taking the square root. So for a square root, you have to know there's an invisible 2 right here. So it's going to be divided by x squared. You can either hit caret and 2, or you can hit this key right here. It automatically squares it for you. Okay. The next step was to go to your table, and you have to start at 0. And it's going to be the largest x value where x and y are both whole numbers. So right here, y starts getting smaller than 1. So we know it's going to be between x being 4 and x being 0. 0 doesn't work. 4 gives you a decimal, so that doesn't work. 2 gives you a decimal for the y, so that doesn't work. So it's either 1 root of 18 or 3 roots of 2. We said we want the largest x, so that would be 3. So my answer is 3 square roots of 2, which is exactly what we got by hand. So at this point, you're going to try some problems. This would be a good time to pause the video again and just look at these steps, and that way you can have these steps written down while you try some of the problems.